right, hello and welcome. In this example, we are going to look at an RL series circuit and determine how long it takes the current to build up to its full value. Right? And we know inductors push back on our current. We know that that current takes time to build up, so we'll call that in terms of seconds. And we want to get to our full value. Our inductors actually never get to a full value, so we use a logarithmic scale to identify that, and we call that our time constant. And so I brought that table out over here, and I even calculated out each one of the time constants here. It's 1 minus the natural log of the time constant, right? And it's to the -1, -2, -3, -4, and -5, and those represent the different time constants, right? And so we see that over here as well, 63.2, and that's right there, and we got 86.5, that's right there, right? And so each one of these is going to represent our different time constants. We see that at the bottom here on the fifth time constant, we're at 99.3%, and we consider that to be 100%. So that means that we need to figure out how long it took us to get all the way up to 100%, all the way through all 5 of our time constants. And we know that we can calculate the length it took our first time constant to be. Right? We'll call that our tau value. And that tau value is the length of every one of these time constants. So once we figure that out, we'll just multiply by the number of time constants that we have, which is 5. Right? So that's what our goal is. So we need to figure out tau, and we'll put that over here. We'll say that our tau is equal to our inductor divided by our resistor. That means that if we want to change our time constant, we need to change our inductor or our resistor. That's going to change our time constant. It's going to change the speed at which our inductor is going to charge to its total current, right? Our resistor is going to slow it down for us. So we'll set that out and we'll say that we have 280 millihenries divided by 48,000, right? 48 kilo ohms. And if we send that into our calculator over here, we've got 0.28, I moved that out of millihenries there, divided by 48,000, 48000. Right? And now we're given a microseconds value. That's our tau. Our tau is equal to 5.83 microseconds, right? That's our time constant. That's the length that it took our time constant to get to the next time constant. So our first one took 5.83 microseconds. Our second one also took 5.83 microseconds, and so did the third, the fourth, and the fifth. So we're going to take this value and we're going to multiply it by our time constants. Multiply by 5. So now we're left with, we'll move that back 1. We'll say we got 29.2 microseconds. That's the total length that it took us to build all the way up to our full value. All right, let us know if you still have any questions.